Welcome to VGuide TV. In this video, I am discussing few questions from force and pressure. We are discussing few questions from force and pressure. Before going for the numericals, I am just revising the equation for pressure. Pressure is nothing but force divided by area. Pressure is nothing but force divided by area. And the apparent weight of a body when it is immersed in a fluid, we can call it as weight apparent is equal to, or apparent weight is equal to actual weight minus buoyant force. Apparent weight is equal to actual weight minus buoyant force. Okay. You can see our force and pressure part 1 and part 2 videos for more conceptual clarity. Now I'll discuss the first question. The first question is a block of mass 4 kg and dimension 10 cm, 20 cm, 30 cm rest on the floor. If G equals 10 meter per second square, then the maximum pressure the block can exert on the floor. So see here, there is a block of mass. The mass of the block is 4 kg. So they gave it in the question, mass of the block is 4 kg. Now this is a block in the sense the block has this part. It has length, it has breadth. The other one what they are given is nothing but, it is nothing but the height. It is nothing but the height, right? The height of the block. So here what we are doing is, we need only these part, okay, because the pressure exerted by the block on the floor they asked. So you have to remember what they gave it here, 10 centimeter into 20 centimeter into 30 centimeter means length into breadth into height. So this is the dimension of the block, length into breadth into height. But when we keep the block like this, the length and breadth are the sides which are in contact with the floor. So the question is, what is the maximum pressure the block can exert on the floor? So near to the floor, length and breadth are in contact. That you should remember. Okay. Now come back to my standard equation. I told you the pressure is nothing but force divided by area. So I am writing the equation, pressure equal force by area. We have written the equation. Next thing is, what is force? Force. Force is nothing but, for the block, in this case of the block, the force is nothing but what is the weight of the block. The force is nothing but the weight of the block. I discussed the mass and weight in one video. So in that I told you the weight is nothing but the force exerted on the body by the earth, or due to acceleration, due to gravity of the earth, we get the weight. Even for our weight also, it is nothing but the force in which the earth is pulling us. So I can write the force is equal to mg. So this is a main equation you have to remember. And this force is also called by a name weight. So when the block is lying on the floor, what is the weight of the block? That is m into g. Mass we know 4 kg into, they gave it in the question gravity value directly. So no need to worry about anything, because gravity they gave it as 10 meter per second square. So I am writing 4 into 10. Okay, and what is 4 into 10? 40, and the unit of force is nothing but Newton. Clear? Unit of force is nothing but Newton. So what I told you, we have written the equation for pressure, force by area. First step we have written here, what is force? M into G. Mass they gave it in the question. G also they gave it. So we calculated. Next part is we have to calculate area. What is area equation? Area is nothing but length into breadth. So what are the length and breadth? The first two dimension, 10 centimeter into 20 centimeter. 10 centimeter into 20 centimeter. 10 centimeter into 20 centimeter is 200 centimeter square. Then next thing you remember, centimeter square is not an SI unit. We need to convert to meter square. So 200 centimeter square by, if you want to convert to centimeter to meter, divided by 100. If you want to convert centimeter square to meter square means it is 100 into 100, 2 times. So 200 by 100 into 100, the unit centimeter square converted to which unit? Meter square. Then how many zeros here? 1, 2, 3, 4. It means 200 divided by 10 to the power of 4. After 1, 4 zeros. When we take this term to numerator, we can write 200 into 10 power minus 4. 200 into 10 power minus 4. So remember, I got the area as 200 into 10 power minus 4. I hope you got it how 10 power minus 4. Because the denominator, how many zeros? 1, 2, 3, 4. It means 10 power 4 in denominator. When denominator term going to numerator, its power changes. So 10 power positive 4 is converted to 10 power negative 4. Clear? So we got an answer 200 into 10 power minus 4. Clear? Now, next is simple only. We are substituting this force and the area in this equation. So we can write force as 40 by area as 200 into 10 power minus 4. Clear? Then 40 into this 10 power minus 4 going to numerator become 10 power 4. What is the meaning of 10 power 4? 4 0. After that, how many more 0? 4 zeros by 200. 2 zeros cancel. 4000 divided by 2. 2000 Newton per meter square. 2000 Newton per meter square. Because the unit of force is, we know it is Newton, and unit of area is meter square. So its unit is 2000 Newton per meter square. Newton per meter square only we can write it as Newton meter per minus 2. So I'll repeat. They are asking in this question pressure. Pressure is force by area. Force, I told you, the weight. Weight is nothing but mg. What is the weight of this block on the ground? So mg. M into g I did. Next is area. Area of this portion. So area is length into breadth. So here, how to convert centimeter square to meter square I told you. 200 by 100 into 100 meter square. So I got 200 into 10 power minus 4 meter square. Next thing is we are substituting 40 by 200 into 10 power minus 4. This term going to numerator. I got 2000 Newton meter per minus 2. Now I'll tell you a shortcut method to convert centimeter square. 1 centimeter square. If you want to convert to meter square, you just write it as into 10 power minus 4 meter square. That's all. Nothing. So what is the meaning of 1 centimeter square? 10 power minus 4 meter square. 10 power minus 4 meter square. So when I got 200 centimeter square, directly if you know this one, 200 centimeter square equal to how many meter square? 200 into 10 power minus 4. How 10 power minus 4? Because in the denominator we are dividing with 100 into 100. So that is the reason we are getting in numerator into 10 power minus 4. So you remember the shortcut formula. 1 by 1 centimeter square converted to meter square means multiply with the 10 power minus 4. 1 centimeter square is 10 power minus 4 meter square. Clear? Next. A body of volume V, density D is completely immersed in a liquid of density rho. Then the apparent weight of the body. I already gave you the formula. The apparent weight is nothing but actual weight minus buoyant force. Actual weight minus buoyant force. So here there is a body. Okay, body is completely immersed. So I'm just taking here, I'm taking a beaker. Okay, in this beaker some fluid is there, and the density of the fluid we are taking it as rho. Okay, what is the density of fluid we are taking? Rho. And there is a body. This is the body, you assume. Okay, and the body density is D, but the body is completely immersed here. So I told you this also in the previous video. What is the apparent weight of the body? So remember, when a body is inside the fluid, the body has two types of forces. One is down, there is a force that is nothing but the weight of the body, and the liquid exert an upward force. The liquid will give an upward force that is called buoyant force. Okay, if you take something inside the water and you see, there will be an upthrust will be there. If you want to dip, if you want to immerse a body inside, the liquid will exert an upward force. That upward force is called buoyant force. Then you remember very important thing, the weight of the body, I can write it as m into g, mass into gravity. Previous question also we did. I told force can also be called by weight. So weight equal mg. Next thing is, you have to remember a formula. Density is equal to mass by volume. It's a very important formula. Density is equal to mass by volume. So what will be mass? Density into volume. Clear? Density formula is mass by volume. So what is mass? Density into volume. So here m into g. In the question they did not give any mass, right? So question they gave volume and density. So I am converting this mass in terms of density into volume. Clear? Mass we are converting density into volume. Density is D, volume is V. According to which formula? Density is equal to mass by volume. So I got a new equation for weight, VdG. Clear? Now, in my equation, I have one more thing called buoyant force. I told you here buoyant force is due to liquid. So it's very simple. You just think it like a liquid means it is nothing but, you can write here, how we can write? FB equals weight of the liquid displaced, or volume immersed, or volume inside into rho into G, or V rho G, because here the total volume of the body is inside the liquid. So instead of V in, I wrote it as V. Okay, in few questions now sometimes they'll give a part is immersed, so that time our condition we will change it. Now you remember V is nothing but our first V only. Rho, you don't forget, rho is density of the liquid. So instead of VdG, equation changes to V rho G. So in simple form you remember buoyant force is V rho G, where rho is nothing but density of liquid. Density of liquid. So I got VdG, V rho G. VdG is the weight, V rho G is the buoyant force. So what will be apparent weight? VdG minus V rho G. VdG minus V rho G. Clear? So what is your answer? V, if you take it common, D minus rho. So the answer is last option. V into D minus rho by G. So in shortcut form you can write it as weight of the body is VdG, where D is the density of the body. Buoyant force is nothing but, what is the buoyant force? V rho G, where rho is the density of the fluid. Clear? Now, this is like a theory question only. See the question. A piece of the wood is floating in water kept in a bottle. Okay, one wood is there, a piece of a wood is floating in water kept in a bottle. In air kept in a bottle. The bottle is connected to an air pump. Neglect the compressibility of water. When more air is pushed into the bottle from the pump, the piece of the wood, what happened for the piece of the wood? We are one water is there, water is kept in a bottle, they told, and at the top we have a wood is there, and the bottle is connected to an air pump. Then if you push more air, what will happen? What will happen when more air is pushed into the bottle from the pump? The piece of the wood will float with a larger part in the water. The piece of the wood will float with larger part of the water. So what is the answer here? By seeing this, you understood the piece of the wood will float with larger part in the water. So in this, which answer is correct? It will float the larger part in the water because the more air we are pushing. So we can tell that the piece of the wood will float with larger part in water because the reason is when more air is pushed into the bottle from the pump, the wood will float with larger part in water. Clear? See the next question. The kerosene of mass 100 grams is mixed with 100 grams of water. Out of the given condition, the well describes the reason of kerosene to float on water. So kerosene and water we are mixing. So according to our Archimedes principle, we know that the weight of the body should be equal to the weight of the water displaced or weight of the liquid displaced. So I can take here the mass of the displaced water is less than the mass of the kerosene. That is wrong. Mass of kerosene is more than the mass of the equal volume of water. Wrong. Mass of kerosene is less than mass of the displaced water. Wrong. The last answer, the mass of the kerosene is equal to the mass of the displaced water according to our Archimedes principle. When a kerosene of mass 100 gram is mixed with 100 gram of water means the mass of the kerosene will be equal to the mass of the displaced water. Clear? So what are the questions we did? We did the question from the Archimedes principle, and the main thing what we did is the questions related to the force and the pressure. Force and the pressure. Force equation is force is nothing but mg. Pressure is nothing but force by area. Weight apparent is actual weight minus buoyant force. And I told you one more thing. Actual weight we can write it as VDG also. Buoyant force we can write it as V rho G, where D is density of body and rho is density of fluid. D is density of body and rho is density of fluid. Clear? Watch all the videos of force and pressure so you will get the better clarity. Please subscribe our channel V-Guide TV and press the bell button. You will get more videos when we update new videos. Thank you for watching V-Guide TV. Thank you.